The Milky Way is an enormous galactic metropolis, spanning over 100,000 light-years across and containing hundreds of billions of stars. For all of human history, our entire existence has been tethered to a microscopic corner of this cosmic city, looking up at the night sky and wondering if we could ever step beyond its outer borders. Leaving our galaxy is perhaps the ultimate frontier of exploration, but the sheer scale of intergalactic space presents obstacles that push the absolute boundaries of physics, engineering, and human biology. To understand the monumental challenge of leaving the Milky Way, one must first grasp the terrifying expanse of space. Traveling between planets within our solar system takes months or years, while reaching the nearest stars requires thousands of years with current technology. However, escaping the galaxy requires crossing the intergalactic void, a vast, virtually empty expanse stretching millions of light-years to the next major galaxy. The nearest spiral neighbor, Andromeda, lies roughly 2.5 million light-years away. Even traveling at the absolute speed limit of the universe, the speed of light, a spacecraft would take over 100,000 years just to pass through the edge of the Milky Way's star halo, and millions of years to reach another galaxy. Current chemical rocketry is completely inadequate for such a journey. A standard rocket would run out of fuel long before even leaving the solar system. To even dream of intergalactic travel, humanity would need radical propulsion breakthroughs. Concepts like nuclear thermal propulsion, antimatter engines, or beamed light sails could theoretically push spacecraft to fractions of the speed of light. Yet, even at 10% of light speed, a journey out of the galaxy would take hundreds of thousands of years. Exotic concepts like Alcubierre warp drives or wormholes offer theoretical loopholes in general relativity by bending spacetime itself, allowing faster-than-light travel without breaking local physics laws. However, these ideas remain firmly in the realm of speculative mathematics, requiring unimaginable amounts of exotic energy that humanity currently has no way to harness or control. Even if the technology existed to propel a ship out of the Milky Way, the biological reality of human beings creates an enormous hurdle. Human bodies evolved under the protective blanket of Earth's atmosphere and magnetic field. Deep space travel exposes humans to intense cosmic radiation and microgravity, both of which severely degrade muscle mass, bone density, and cellular DNA. A journey lasting generations would require multi-generational colony ships where hundreds of human lifespans begin and end inside an artificial ecosystem. Sustaining life in a completely closed loop for tens of thousands of years without any chance of resupply from Earth introduces catastrophic risks of hardware failure, genetic bottlenecking, and social collapse over time. Instead of biological humans, the first travelers to leave the Milky Way may not be human at all. Self-replicating autonomous probes driven by advanced artificial intelligence could be sent out as vanguard explorers. Alternatively, future advances in biotechnology and cybernetics might alter what it means to be human, transitioning our species into post-biological entities, digital consciousnesses, or immortal synthetic organisms capable of enduring multimillennial journeys across intergalactic space. Ultimately, whether humanity ever leaves the Milky Way depends on how long our civilization survives and how far we are willing to push the boundaries of scientific understanding.